Today in this session, we will discuss about chi-square test. Chi-square test is a statistical test used to determine if there is a significant association between two categorical variables. It is based on the chi-square statistics, which measures the difference between observed frequency and expected frequency. So for this, we will consider two variables, two categorical features, gender and games. In gender, we have two categories, male and female. In games, we have two categories, tennis and cricket. So our aim is to find whether is there any association between gender and games, whether there is no. So we will follow step-by-step process to do the chi-square test. In the first step, we do start by stating the null hypothesis and the alternate hypothesis. The null hypothesis typically associates that there is no association between the variables, while the alternate hypothesis suggests that there is an association. So in the first step, we need to consider our null hypothesis and alternate hypothesis. So null hypothesis, H naught. There is no association between gender and games. Whereas alternate hypothesis states that there is association between gender and games. So this is our first step. In the second step, we need to create a contingency table. Construct a contingency table or a cross tabulation that summarizes the observed frequency for each combination of the categorical variables. So in the second step, we need to construct a contingency table. So the rows represents the gender, male and female. Here the column represents the games, cricket and tennis. Suppose 70 people choose cricket as their favorite game. Suppose 30 male people choose tennis as their favorite game. 80 females choose cricket as their favorite game. 20 females choose tennis as their favorite game. So here the row total 70 plus 30 gives 100. For females, the row total 80 plus 20 gives 100. Coming to the column total, 70 plus 80 gives 150 as column total for cricket. 30 plus 50 gives 50 as column total for tennis. Here 200 is the grand total. So this is the second step, constructing a contingency table. Coming to the third step, determine the expected frequency under the assumption of dependence between the variables. The expected frequency for each cell is calculated as row total into column total by grand total. So here we need to calculate the expected frequency for each observed frequency. Suppose 70 is our observed frequency for male cricket, 30 is our observed frequency for male tennis, 80 is our observed frequency for female cricket, like 20 also. So here we need to calculate the expected frequency for each observed frequency. So expected frequency for 70 is equal to, here we use formula row total into column total divided by grand total. For 70 observed frequency, row total is 100 and the column total is 150. Grand total is 200. So we need to multiply 100 with 150 and divided by 200. So this gives 75. So 75 is our expected frequency for 70. Coming to expected frequency for 30. The same formula we use. So for 30, row total is 100 into column total is 50 divided by grand total is 200. So this gives 25. So for the rest of the two observations also, we can do the same calculation. Expected frequency of 80, expected frequency of 20. So we need to make like a table. So the first column represents the observed frequency. And the second column represents the expected frequency. So what are our observed frequency? 70, 30, 80, 20. 70, 30, 80, 20. So we get observed frequency for 70 is 75 and expected frequency for 30 is 25. Similarly, we can get for 80, 75 as our expected frequency and 25 as our expected frequency. So coming to the next step, compute the chi-square statistic. Calculate the chi-square statistic by summarizing the square differences between the observed and expected frequency for each cell divided by the expected frequency. This is done for all cells in the contingency table. So coming to the next step, we need to calculate the chi-square value. So for this, we need to construct a table. So in the first column, observed frequency. In the second column, expected frequency. In the third column, we represent a formula, which is the difference of observed frequency minus expected frequency. In the fourth column, we do a square of difference between observed frequency minus expected frequency, whole square. And in the last column, we do observed frequency minus expected frequency whole square by expected frequency. So coming to the values, what are our observed frequency values? 70, 30, 80, 20. Coming to the expected frequencies, 75, 25, 75, 25. So observe this column, observed frequency minus expected frequency. That means 70 minus 75, which gives minus 5. 30 minus 25 plus 5. 80 minus 5 plus 5. 20 minus 25 minus 5. And square of this each value. Minus 5 whole square gives 25. Plus 5 whole square gives 25. Same 25. Same 25. So we have to divide this 25 with each expected frequency values. That means 25 divided by 75, which gives 0.33. And 25 divided by 25, which gives 1. 25 divided by 75, same 0.33. 25 divided by 25 gives 1. So we need to do summation of all these values. So here the total is equal to 0.33 plus 1 plus 0.33 plus 1, which gives 2.66. So the chi-square formula is chi-square is equal to sigma of observed frequency minus expected frequency whole square by expected frequency, which we get 2.66 is our calculated chi-square frequency value. So now the next step is determine the degree of freedom. Degree of freedom are calculated based on the number of rows and columns in the contingency table. For a 2 by 2 table, degree of freedom is 1. For a larger tables, the degree of freedom is number of rows minus 1 into number of columns minus 1. So here our contingency table is a 2 by 2 table. So to calculate the degree of freedom, we use a formula. Number of rows minus 1 into number of columns minus 1. So in this step, we need to calculate degree of freedom. Degree of freedom is equal to number of rows minus 1 into number of columns minus 1. So here we use 2 by 2 contingency table. That means 2 rows and 2 columns. So 2 rows, 2 columns. So we take 2 minus 1 into number of columns 2 minus 1. So which gives 1 into 1 is equal to 1. So here degree of freedom is 1. Now we need to consider the significance level. Significance level. Suppose if you consider significance level of 0.04, it's completely depends upon the user. So if you consider the significance level of 0.05, you need to download this particular table from Google. Just type a significance level table in Google Chrome. You can find this table. So whenever the degree of freedom is 1, so if you observe here, whenever the degree of freedom is 1 with a corresponding significance level of 0.05, the corresponding value is 3.841. So for a degree of freedom 1 and significance level of 0.05, our chi-square value from table is 3.841. Observe here. But our calculated chi-square value from the contingency table is 2.66. So compare these two values. 2.66 is our calculated value. 3.841 is our chi-square value from the table. So if you observe here, 2.66 is less than 3.88. If the calculated value is less than the table value, then we accept the null hypothesis. We accept the null hypothesis. Null hypothesis. If the calculated value is greater than, the calculated value is greater than the table value, we reject the null hypothesis. We reject the null hypothesis. That means accepting the alternate hypothesis. Accepting the alternate hypothesis. But here in this case, we get calculated value as 2.66 and the table value is 3.841. That means the calculated value is less than the table value. So we need to accept the null hypothesis. What is our null hypothesis? There is no association between the gender and the games. So gender and games, there is no association between them. Here, like this way, we will calculate whether there is any association between the two categorical variables